So here we are with a very wonderful question from the concept of coordinate geometry, we can say, or more precisely circles. So it looks like a question that can be solved with calculus, but no, it's not a question that we are going to solve with calculus. Obviously, we can solve this question with calculus, but today we are going to maximize angle, or you can say find the maximum possible angle. That's what's the demand of the question without using any kind of calculus, and that's what coordinate geometry comes into action. And this problem we will be covering four concepts through a single problem, and all of these problems are very important for any kind of exams that we are going to appear, let it be JEE or anything else. So first, let's go through the formal wording of the question. Given are 2 points M and N in a plane rectangular coordinate system, we can say the x y system. P is moving point on the x-axis. P is moving point on the x-axis. When angle M and P takes maximum value, we need to find the x coordinate of P. So first of all, let me give a hint of how to solve the problem using calculus. For calculus method, what we will do, we'll take P as a point h comma 0, h comma 0. Now you'll find out the distances MP, NP, and the distance Mn is fixed because we know the coordinates of the point. And then we'll apply cos theta, or you can say cos angle M and P. Cos angle M and P, and we can write cos angle M and P in terms of MP, NP, Mn using the cosine rule. Cosine rule, and then we'll use calculus or application of derivative, whatever you say it, to find out the maximum value of cos theta, and we'll use the idea of some kind of increasing decreasing function to get the final value. That's the calculus approach. Now let's go with the geometry approach, or you can say coordinate geometry approach, or approach using the concepts of circle. That's the most beautiful approach. Let's go through the first diagram. See, this kind of concept and this kind of questions we can never solve if we don't know the approach. There are four concepts here in a single problem. Four concepts in a single problem. So when four such concepts are merged, this kind of solution, the normal solution that we will get for this question that's available in internet on any market books, they will use this calculus method, but we are using complete non-calculus method to solve this kind of wonderful problem. And that's why it becomes very important. We are not going to predict a question for the JEE, but what we are going to do is predict the concepts, and those concepts which students doesn't usually focus on the normal classrooms. These are not usually focused or given less focus, because who does cares to solve a problem of calculus using coordinate geometry? Nobody does this kind of out of the box thinking that we're going to do here. First of all, this is the line MN. This is the line MN. Let me assume 3 points P here, because P is a moving point. Let's consider it as P0, P1 and P2. These are 3 points. Now let's observe one thing. Let's observe one thing. Let this angle be alpha, this angle is beta, this angle is gamma, this angle M P0n, angle M P1n, angle M P2n are alpha, beta, gamma respectively. How do you compare this alpha, beta, gamma? How do you compare this alpha, beta, gamma? Let's see. Let's see. First of all, we need to see that this angle MP0n, this angle is on the minor arc of the circle, is on the minor arc of the circle. So obviously angle MP0n is going to be obtuse angle, and this is the concept one. And if we look carefully, these angles, this angle and this angle, this angle and this angle, because this is the circle, this is the circle for the angle beta, and we can clearly see this is the chord, this is the chord, This is the chord. This is the circle. We can clearly see that this is the measure arc of this respective circle. So it is quite obvious that angle subtended on the measure arc is obviously an acute angle. So only obtuse angle here is MP0n. So obviously this alpha is greater than this beta and gamma, and that's the first conclusion we are drawing out. So, and this is indeed the motivation of the problem. This is indeed the motivation of the problem. So let's go to the motivation of the problem, because this is the thing that we need to focus, or you can say concept one. Angle subtended by chord on an arc of a circle. This is the basic concept that we should know. First of all, when AB is diameter of a circle, this is so frequently used in JEE questions. It will subtend 90 degree on the arc of a circle when AB is diameter. This is a very important concept. These are related concepts that we should keep in mind. Always we should keep in mind. Sometimes they will give you a right angle triangle. They will give you a right angle triangle and ask for the circumcenter of the circumcircle of the triangle. So what is the circumcenter? The midpoint of the hypotenuse of a right angle triangle is the circumcenter. And that's quite obvious from this diagram. Now, let's say that this is a chord of a circle. This is a chord of a circle. Angle subtended by it on the minor arc is an obtuse angle that is greater than 90 degree, and angle subtended by it on the major arc is always an acute angle less than 90 degree. And obviously we know that angle subtended from a same chord, 2 points on the arc which are on the same side of this chord, these 2 points are on the same side of this chord, subtends equal angle. And we also know that angle subtended by chord on the arc of a circle is half of the angle subtended by it on the center of the circle respectively. So these are the things that we should know about angle subtended by a chord on a circle. These are the concepts that we should keep in our mind while solving any kind of problems. So this is concept one. Now let us go to concept two and start solving the problem very slowly. Let's go back to this diagram. The first question that comes in my mind, that where does actually the center of this circle lies? The center of this circle, red circle, lies. Mn is a chord of a circle. Mn is a chord of a circle, and we know that perpendicular bisector of a chord of a circle, perpendicular bisector of chord of the circle passes through the center. So can we say that center lies on the perpendicular bisector of Mn? This is concept 2. This is concept 2. Concept 2. The center of circle passing through Mn is on the perpendicular bisector of y equals to 3 minus x of Mn. So now we can write the parametric coordinate. Let us assume x as a. Then y will be 3 minus a. This is the parametric coordinate of the center of the circle. Now we can also write the equation of the circle. Equation of the circle passing through Mn. This is the equation of circle. How we know the radius of the circle? How we know the radius of circle? Because m and n points are known to us. We can simply find the distance of mn. We can simply find out the distance of any point m or n with the center s a comma 3 minus a, and we'll get this. This is the radius of the circle. This is the radius of the circle. Now, the circle S through 3 point M and P will subtend maximum angle on the x-axis, as we have seen in this diagram, when this P is tangential point. So now we'll apply condition of tangency, that you can say concept 3. What is condition of tangency for a circle? Given a circle, how do you determine? Given a circle, we know the center of the circle is some g comma f. Center of the circle is g comma f. The equation of this line is given as y equals to mx plus c, and we know the radius of the circle is given as r. How do we apply condition of tangency? Condition of tangency is nothing else. We would find out the perpendicular distance from this tangent to center, or from this line y equals to mx from center, is equals to r. That is the condition of tangency. perpendicular distance of this line from the center is equal to the radius, and this is the condition of tangency that we have applied here. Here we applied condition of tangency because x-axis is the condition of tangency, and the perpendicular distance from x-axis is nothing else but 3 minus a, 3 minus a, and that's equals to the radius. Actually, what was this? This is radius square. This is radius square. Sorry. This is radius square. This is r square. And this is also perpendicular distance whole square. And that's why mod is not being used. Otherwise, we need to use modulus if we don't use the square. Solving this, we have two values of a equals to 1 and a equals to minus 7. So you can find out the point of contacts. This point of contacts are 1, 0, minus 7, 0. Now there are two possibilities, and we need to figure out in which possibility this angle MPN is going to be maximum. For this, we can either manually find out the values of the angle MPN and MP dash and figure out which is greater, but this is going to be a lengthy method. So here we are going to apply the fourth concept and the last concept of these problems. Yes, we find out the respective equation of circles according to different values of a equals to 1 and a equals to minus 7, and these are the, when a equals to minus 1, this is the equation of the circle, and when a equals to minus 7, when a equals to 1, when a equals to 1, and when a equals to minus 7, these are the respective equation of the circles. Now this is the diagram. This is our line, or you can say chord MN. This is the first circle with smaller radius, as we have seen. Its radius is 2. Its radius is 2 and its radius is 10. So among them, which angle is larger? This angle or this angle? How do you conclude? Very easy method to conclude. Let's see. Here we are applying the sine law. For a triangle, we know that. For a triangle, these are the sides. These are the sides ABC, and these are the angle ABC respectively, and R is the circumradius. R is the circumradius. We know that. A over sine alpha. B over, not alpha, sorry, sine A. B over sine B. C over sine C equals to 2R. And that's the thing that we have applied here. From the figure, it's quite evident and quite clear to us that these circles, both of these are the major arc. Both of these are the major arc. Contradictory to what we assumed in the initial diagram, because that was the rough diagram and this is the accurate diagram. Both of these are the major arc with respect to the chord MN. So we can say that both of these angles are acute. But it's quite obvious that angle is maximum when x is tangent to the circle. X is tangent to circle. So we can say that this is the maximum acute angle. This is the maximum acute angle possible, or maximum angle possible, whatever you say. Because angle, to maximize angle, that's the concept that we're using. That can turn out to be acute also sometimes. But this is where we get the maximum angle. Now among them, this radius is smaller, this radius is smaller. We have the graph of sine. This is x equals to pi by 2. This is x equals to 0. From 0 to pi by 2, sin x is an increasing function. As the value of alpha increases, value of sin alpha also increases. Let's try to clarify the doubt. Okay, before that, let's find out which angle is larger, the angle MP dash n or MPN. Clearly, we can see for the case of angle MPN, this angle, the radius is smaller. As the radius is smaller and they have an inverse relationship among them, as Mn is constant. Length of Mn is given and is a constant. So you can clearly conclude here that alpha here, or the angle MPN, is going to be maximum for the case when radius is smaller. So this is our required case, the smaller circle, and hence we conclude that the value of P, that's the coordinate of P, is 1, 0. Now let's try to find out the reason or figure out that in spite of the fact that this angle is not an obtuse angle, in spite of the fact that where it forms the tangent is an acute angle, this is an acute angle, still we are getting the maximum possible angle here. But at the very beginning of the problem, what we have seen that we considered this case of tangency because alpha was coming out to be a obtuse angle in the rough diagram that we have. Actually, there's nothing to confuse about. When they are acute, we consider that if it is obtuse, if alpha greater than 90, for that case we generalized. When alpha is less than 90, at the very end of this, the fourth concept, we took the sine rule. We can see that alpha increases when radius decreases, and the least possible radius is the case when this x-axis becomes a tangent to the circle, and that's why we are getting the desired result as the value of P as 1, 0, because in this case when they are acute and we need angle maximization, the radius should be smaller, or you can say the smallest, and smallest radius is given by the case of tangency. And that's the beauty of this problem, that the first concept or the first motivation of the problem turns out wrong, but we get the correct answer because of the last step. And that's the beauty of solving a question that's generally solved using calculus in all the books without using any kind of calculus, but simple application of coordinate geometry and circle.